One of 3D printing's greatest features is to make the abstract real. This ability makes it an excellent choice for math classrooms. Often, mathematical concepts are difficult for students to fully understand. 3D printed models and manipulatives can help deepen understanding and spark interest and enthusiasm. First, let's take a peek at the standards for mathematical practice. You will be able to see the connections to 3D printing right away. Making use of a 3D printer, math manipulatives, and printing projects can help students achieve these standards. First, the first standard is to make sense of problems and persevere in solving them. Then, reason abstractly and quantitatively, construct viable arguments, and critique the reasoning of others, model with mathematics, use appropriate tools strategically, attend to precision, look for and make use of structure, and look for and express regularity and repeated reasoning. All of these standards are applicable to 3D printing design projects, as well as using 3D printed models and manipulatives in your teaching. So let's look at some examples. We can make a model of the classroom to teach measurement and scale. We can explore the properties of geometric shapes. And this one is really cool. You can physically represent equations, so students can visually see and touch the difference between z equals x squared plus y squared and z equals x plus y together squared. Fractions, we can use 3D printing to help learn fractions and teach things like similar and congruent shapes, area, volume, perimeter. The possibilities really are endless. This is a nice video that shows an example of a math manipulative to teach the effects of coefficients in equations.
This 3D printed manipulative will help you better understand the parabolas generated from by graphing a quadratic function. The quadratic function of the form ax squared plus bx plus c. The a coefficient and the c coefficient are pretty easy to understand, but the way that the b coefficient affects the parabola is a little bit counterintuitive. So this manipulative will kind of help you understand that. So the b coefficient is really a slope of a line that pushes the parabola up and down, like this. So when b is 0, you get the parabola right at the origin. And when you increase b, it increases the slope, and that ends up shifting the parabola to the left, and actually down a little bit. And when you decrease the slope, it ends up shifting the parabola over to the right. And so by playing with this manipulative, you can get a better understanding of how the b coefficient affects the graph of a quadratic function.
Thank you so much for listening, and I am always available for any questions or collaboration, and I am looking forward to working with you in the 3D printer in your math classrooms.